डियर स्टूडेंट, हाउ आर यू। और अपने इस लेक्चर में इस चैप्टर की वेरी इंपॉर्टेंट टॉपिक थ्रेशोल्ड एनर्जी एंड एक्टिवेशन एनर्जी वी आर गोइंग टू डिस्कस। केमिकल काइनेटिक्स का वेरी वेरी इंपॉर्टेंट टॉपिक थ्रेशोल्ड एनर्जी एज वेल एज एक्टिवेशन एनर्जी। क्लियर? देन फर्स्ट ऑफ ऑल वी हैव टू डिस्कस अबाउट द थ्रेशोल्ड एनर्जी। That minimum amount of energy which is required to reactant to convert into product is called threshold energy. मीन्स किसी भी केमिकल रिएक्शन में रिएक्टेंट को प्रोडक्ट में बदलने के लिए रिएक्टेंट के लिए जो रिक्वायर्ड एनर्जी होती है, जिसके बिना रिएक्टेंट प्रोडक्ट में कन्वर्ट नहीं हो सकते, उस एनर्जी को हम बोलते हैं थ्रेशोल्ड एनर्जी। मीन्स दैट energy which is required to reactants to convert into products is called थ्रेशोल्ड एनर्जी। राइट? इसको थ्रेशोल्ड एनर्जी कहते हैं। विदाउट थ्रेशोल्ड एनर्जी रिएक्टेंट कांट कन्वर्ट इनटू प्रोडक्ट्स। देन व्हाट इज द एक्टिवेशन एनर्जी? एक्टिवेशन एनर्जी it is denoted by EA, energy of activation या activation energy. What is this? What do you mean by the activation energy? क्या होती है? That minimum amount of energy which is provided to reactants so that their average energy becomes equal to threshold energy. Okay, then the provided energy is known as एक्टिवेशन एनर्जी। एक्टिवेशन एनर्जी के लिए उन रिएक्शन के लिए जरूरत पड़ती है जिनके रिएक्टेंट की एवरेज एनर्जी थ्रेशोल्ड एनर्जी की इक्वल नहीं होती। एंड यू नो वेल, जब तक रिएक्टेंट की एवरेज एनर्जी कांट इक्वल टू थ्रेशोल्ड एनर्जी, देन रिएक्टेंट कांट कन्वर्ट इनटू प्रोडक्ट। अल्टीमेटली एडिशनली उनको एनर्जी प्रोवाइड की जाती है ताकि उनकी एवरेज एनर्जी थ्रेशोल्ड एनर्जी की इक्वल हो सके। देन द सप्लाइड अमाउंट ऑफ एनर्जी is known as activation energy. Means that minimum energy which is provided to reactants, so that their average energy becomes equal to threshold energy is called activation energy. Then it is known as activation energy denoted by EA. Okay? This is known as activation energy. Ultimately you can form this relation. Therefore threshold energy equal to एक्टिवेशन एनर्जी प्लस एवरेज एनर्जी ऑफ रिएक्टेंट्स। दिस इज द थ्रेशोल्ड एनर्जी। दिस इज द combination of activation energy as well as average energy of reactants. Okay, you can also declare it as you can also declare it this relation which is implies activation energy is equal to threshold energy minus average energy. Threshold energy minus average energy of reactants. Okay, this is now known as activation energy. And what is the actual role of activation energy? How it used to turn the mode of reactant to convert into product? क्या ऐसा करती है एक्टिवेशन एनर्जी? किसी रिएक्शन के साथ मिल करके रिएक्टेंट को प्रोडक्ट में कन्वर्ट करने में कैसे सहायक है? सी है. Say about it. Okay. What is the role of activation energy? Means contribution of activation energy. Actually, activation energy used to combine with reactants. Activation energy used to combine with reactant. Then reactant used to form a complex state of reactant. The reactant used to form a complex state, a transition state, which is unstable. क्यों अनस्टेबल हो जाती? Because that unstable state has maximum value of activation energy. So it becomes more unstable and used to decompose in next moment to form the product. This is the major contribution of activation energy. Means reactant first of all activation energy को absorb करके gain करके एक complex state बनाते हैं reactants की which is unstable and used to decompose to form the main product. Okay, for example see, this is the H2 and I2. No doubt this is the example of slow velocity reaction, and activation energy is actually applicable for the slow velocity reaction. Then this reactant used to gain activation energy. Then these used to form a transition state. What is the transition state? See here. This is the transition state or complex compound. Complex state. This one is unstable. This is unstable and having maximum value of activation energy. On next moment it will decompose, self decompose to form the main product. This is the major contribution of activation energy, and through this concept you can clear, and that is also going to clear properly, that activation energy used to increase the path of reaction. Hence we can declare that the higher value of activation energy of any chemical reaction used to decrease its rate of reaction. जिस केमिकल रिएक्शन की एक्टिवेशन एनर्जी की वैल्यू जितनी ज्यादा होगी, रेट ऑफ रिएक्शन उसकी उतनी स्लो होगी. Why? Because activation energy is responsible to increase the path of reaction. आप इसमें देख रहे हैं, ये दोनों मिलकर डायरेक्ट प्रोडक्ट नहीं बना रहे हैं. First of all, a transition state of complex compound is going to form. It is unstable, and when it will decompose, then the main product is going to form. Ultimately, it will take more time, and on account of more time, taking more time, rate of reaction used to decrease. It can also explain on the basis of graph. We can also explain it on the basis of graph. Now seeds, graphical contribution. Its graphical representation. Now its graphical representation. How will you represent to the contribution of activation energy? With the help of graph for the same reaction. See. This is the graphical representation. Along y-axis, we have taken the value of activation energy or potential energy. And here reaction coordinate means contribution of reaction coordinate along x-axis. Okay? What happens? See. Try to see. Here the reactant. See properly. This one. Y-axis. And here the reactants are H2 plus I2. Okay? At the maximum value of, means at the peak of activation energy, H2 and I2 both used to form a transition state. This is the transition state in a complex compound. It used to form a complex compound as the maximum value of activation energy. And finally, here is the possibility of the formation of product. So you can notice here this path is going to increase on account of the contribution of activation energy. So its rate of formation of product used to decrease. And you know the difference of label both. This is counted as the enthalpy change. When heat is going to evapor, heat used to release. Then the enthalpy change, the difference of the reactant as well as between the product. And this is contribution of activation energy without catalyst. Without catalyst. And suppose we have to take any catalyst in this reaction. या इस रिएक्शन में कोई कैटलिस्ट यूज करते हैं. Suppose we are going to use any catalyst, then you know its activation energy used to decrease. Why? Because rate of reaction used to increase. Very important point ध्यान रखिए. How the presence of catalyst used to affect to rate of reaction as well as activation energy of reaction. A positive catalyst used to increase the rate of reaction. Why? Because presence of catalyst used to decrease to the value of activation energy. See, यदि इसी में catalyst use करते हैं, then what is the view? Then this is the way with a without catalyst है, a with catalyst. Then a transition state will form here. ये जो ट्रांजिशन स्टेट यहां पे फॉर्म हो रही है, इट विल फॉर्म हियर. अल्टीमेटली यू कैन नोटिस हियर द पाथ ऑफ रिएक्शन इज गोइंग टू डिक्रीज. व्हेन द पाथ ऑफ रिएक्शन इज गोइंग टू डिक्रीज, नो डाउट rate of reaction used to increase, and hence we can declare that activation energy used to decrease the rate of reaction. And if you will select any positive catalyst, then the rate of positive catalyst used to increase the rate of reaction by decreasing द वैल्यू ऑफ एक्टिवेशन एनर्जी। एक्टिवेशन एनर्जी कम हो जाएगी, तो ट्रांजिशन स्टेट पहले बन जाएगी, तो पाथ कम चलना पड़ेगा, पाथ ऑफ रिएक्शन यूज टू डिक्रीज, और पाथ जब कम होगा तो प्रोडक्ट जल्दी बनेगा। इट मीन्स रेट ऑफ रिएक्शन यूज टू इंक्रीज। ओके, थैंक यू।